There's more paper produced writing about cylinder bores than any other surface in the world.
I was told to make one engine that fits maybe 3 different applications. It's a hard balance.
I didn't have a customer. I just had an idea that there might be a market for software that helps people understand their surfaces.
We had a few engines that would burn oil. Our finish looked like a mirror. How can that be?
If you don't have the money to buy expensive measuring equipment, maybe the engine will tell you.
I know this worked for this application. Let me just duplicate it.
To try to describe a surface with a number is like trying to describe a concert based on its decibels. You know, Taylor Swift was awesome. She was 105 decibels. Well, so is the chainsaw.
Yeah, because you don't want to be burning oil, and then the pollution and everything like that is you're trying to minimize that.
You're using, you know, the eyes I can help provide, but your brains.
Yeah.
And that's awesome.
Everybody, welcome back to another episode of The Builder's Lounge. It's always a good day because I feel like we've been so blessed with the guests that we have on here. Today is really special because we have a friend and a genius, in our opinion. His name is Mark Malburg. He is owner of Digital Metrology. When it comes to precision, this guy knows what he's talking about. He has a PhD in this field, and he's come here to our facility to train us. We're blown away each time we talk with him or meet with him at how kind he is, but also how professional and intelligent he is when it comes to the world of measurement, exactness, surface finish, everything like that. Mark, thank you so much for being here. We look forward to really learning about what kind of things to look out for when it comes to surface finish, measurements, and all of that stuff. So thank you for being here with us.
Cool. Well, this is fun. Thank you for having me. I appreciate it.
Yes. Now, you've come out and visited us before, given us some trainings. Will you tell us a little bit before so that everybody can get to know you and who you are? A little bit about Digital Metrology, your company, what you've designed and what you've developed. And then we'll get to know you personally a little bit better as well.
Sure. I am really in the business of helping people see things. It's a strange place to be because I get to see a lot of things. I work in, cars and automotive as much as perhaps all my other fields combined, but I work in sporting goods and paper products and optics, pretty much anything with a critical surface. It seems like I've touched it in one way or another. So my experience is very, very broad, and somehow people want to think it's very deep because they'll say, "Hey, Mark, I've got a moly ring and a cast iron block. What should it be?" Man, I don't know. I can help you see it.
Yeah.
Because that's my job, is to be eyes for people so they can understand how to apply their expertise. So it's an awesome field to be in because, like I said, I get to turn light bulbs on for people. That's what wakes me up in the morning, is I get to go turn on light bulbs.
I like that. So tell us what a world would look like without metrology. And that world encompasses so many different things. So I guess, can you tell us how broad it is and then how narrow it is as well for people like the regular car enthusiast that's just likes driving his car and wants to know about that, or just the daily person? Like, why is this, sounds bad to ask you, but why does metrology matter and why is it important in our daily life?
Sure. I mean, it matters deeply to me. I mean, it's my career. So that's it. There you go.
That's a great answer.
So first off, metrology is a big word. There's fluids metrology, there's electrical metrology, there is a whole world of legal metrology. If you look at a gas pump, there's a certificate on it from a metrology department
I did not know that.
Calibrates and handles the measurement of volumes. So metrology is literally measurement science.
Okay.
I am in the world of dimensional metrology in a subchapter called surface metrology.
Yeah.
So I work in the world of length and height and width, but more specifically in the surface shape world.
Okay.
So there's a big capital M metrology that's anything to do with measurement. In dimensional metrology, it affects everything in our daily lives. If you plug something into a wall, there was metrology behind it to make sure the plug matches the outlet.
Interesting.
They have to be the right dimensions.
Right.
Those are standardized
Right.
and they're measured with metrology.
Yeah.
If you plug that thing into the wall, there was electrical metrology to make sure the device was built to handle whatever voltage the wall was built to supply.
Yeah.
So there are standards and there are measurements for voltage that go into something as simple as plugging that device in.
Right.
There is chemical metrology going on regarding the plastics that can be used to plug something in that aren't going to conduct and that kind of things. So there's materials kinds of metrology. Anything that's measured is metrology. If the guys building the railroad didn't use the same metrology as the guys building the train wouldn't fit on the train tracks.
Right.
So yeah, it's in every area. Bringing it down a little more personal, we are touching surface metrology every day. This is my old iPhone 7. I love it for an example. You can see the reflection on the screen where it's dull and kind of matte finish here,
Right.
and then the logo is shiny. So that surface is a great example of designing something with surface metrology to have a feel and a look. We're designing it to feel nice in your hand and to have that nice look, but we can extend that into the world of friction. So my world of surface metrology, measuring surfaces, is used for things like appearance and sealing and things. So we're using metrology tools to describe things.
Right.
But if you remember high school science class, you might have had a segment on the topic of friction. Let me pull up a little video that I made on my iPhone regarding friction. So surface measurement, give it a share here, helps us understand things like friction. And you would imagine if something is rough, it's going to have more friction. Sandpaper is rough and it has a lot of friction.
Right.
Well, if we look at the iPhone, the rough surface is slippery. My finger slides all over it until it touches the apple. The smooth surface is actually sticky.
Right.
My finger sticks to the apple but slides on the rough part. That's backwards to our science class.
Right.
Science class said rough means more friction and smooth means less. So these kinds of things are quite difficult to explain, but it comes down to, rubber versus metal and things like that, and your fingers are essentially rubber. So those areas, we can extend that farther, though. We can take measurements into tiny places that are having a huge impact today. I was on one project where a bump, just a little lump in a piston pin bore. So you've got a piston pin going through the piston. This lump was half the height of the thickness of your hair, or half the thickness of your hair.
Wow.
Just a small lump in the surface that was half a hair tall would cause an engine to completely break apart.
Wow.
Not just scuff and come to a screeching halt, but literally break an engine. The piston would slam around and break an engine block over just a tiny little lump in the surface.
Wow.
We're doing things today that are super cool, where we're using X-ray now in our metrology, and we can X-ray into a fuel injector and see the spray holes. And we have other microscope systems that can do the same thing now, where we can use a microscope technology with just lenses, and the company Alicona is doing this, and we can look in the hole and see the shape of the hole. It's crazy to think if you picked up a paper towel roll and looked down the hole and measured while looking down the hole.
Right.
So amazing measurements. And by the way, the shape of these things matters deeply to the performance of a fuel injector.
Right.
Not just a hole, but it's the right shaped hole. And in this world of surfaces, everything seems to matter. A car company launched a really high-end car, and the reviews were, everything about this car is fantastic. The engine, the ride, the feel, the quietness, everything about it is amazing, except the interior makes us call it that into doubt. The interior is a little plasticky, so we're questioning everything. It's like, wait a minute, you just said everything was great, but the feel of it, and at this microscopic scale, this feel scale, makes you doubt everything else. So metrology is a really broad field that I just happen to live in a tiny little lane of that world.
I would not think, I wouldn't have thought until we met you and until talking with you that it had such an importance on, everybody's phone. You wouldn't think twice about it normally.
Right.
Or the feel of when you get into a car and if it's plastic versus a different material or whatever, you just go about life almost and don't think about those things too much. But it's interesting to see people like yourselves that are behind this curtain and doing all of these things, how much importance it has.
It is, and it's a weird psychological world as well, because some of these situations, a company making computer Wi-Fi routers, they want them all to look the same. And if they don't all look the same on the shelf in the store, people say, well, is that a quality problem? There was a company that makes surgical or medical staplers. Yeah, let's go there. Let's get Frankenstein here. If you get an injury or a surgery and they staple it instead of stitch it.
Right.
The company was making these staplers and they changed the texture of the plastic on the handle. And they shipped them to the hospitals. And these hospitals, they're disposable. Okay. So they staple you and then they throw it away because it's not sterile anymore.
Right.
The hospital received the new ones and they were a slightly different texture because they used new molds, and they immediately sent all the new ones back.
Oh.
They didn't trust them.
Because they were different.
So
it was a different feel.
It was different, and therefore it must be wrong. We can't trust it because it's different. So this world is a psychological world as much as a performance world.
Right. Very interesting.
So when you sit and look at pictures of your honed surface, that's truly the art side of this. You get to use both sides of your brain.
Right. The artistic and side, and then the technical side.
Right.
And now you've mentioned that your experience is so broad. What kind of companies have you been involved in that you've helped develop? How something feels or the finish of it. Do you have any like big companies or that are noteworthy you've worked with, so people know?
Yes, but they practically all make me sign a non-disclosure agreement.
Dang it.
So you would recognize many of the names.
Yeah.
And so, for example, I won't name names, but I work for all of the big three. I work for big companies that do things like contact lenses and eye implants, and companies that make cell phones and laptops and routers and computer components, speakers, earbuds. It's wide, and I'm sorry I can't drop names.
That's okay. I was hoping for it. I knew that may be your answer, but
so one place to see some of the names would be, for example, in my blog and Digital Metrology's website, there is the Surface Notes section, and we do interview people along the way. Like we interviewed an engineer from Safina who does micro finishing, and they're big OmniSurf users there. There's an interview with the guys at Ping Golf. They're big OmniSurf 3D users in the design of golf clubs. Yeah. So there are some that I have in the blog that have released it.
Yeah.
But in general, man, I wish I could tell you.
Yeah. Well, it's so fascinating every time that I talk with you to hear about how many different things you're involved in that from my perspective is like, oh, I didn't even know that people were considering like the surface finish or the measurement or whatever on certain things like this. But they put a lot of research and time and bring in the best brains like yourself to help figure that out. So it's always interesting to hear.
Yeah, and it surprises me. I mean, I'm still presented with weird things like earbuds one day. Hey, the left earbud doesn't look like the right earbud when we put them in the case.
Yeah.
And customers think, they're cheap because they don't match. So things like that it's crazy. Very different world of describing surfaces to your eye as compared to when it's rubbing together in an engine.
Yeah. Now you have a PhD in this field. When did you know that this is the world you wanted to be a part of? And when did that start for you?
Dude, that's a deep one. I don't know. Is this a Little Mermaid part of your world kind of thing you want to sing with me or what?
We could
Uh,
break out in a musical. I'm
all
ready
right,
for it. Let's do
you lead.
it.
um, You know, I don't know. I think metrology kind of caught my eye as a summer intern working actually in the measurement of turbine blades for jet engines.
Oh wow.
And it was fascinating that you could mathematically predict something and then measure it and see, reality meeting theory. And I think that's what caught my attention was metrology is that link between kind of theory and reality and what do you have and what do you really have compared to what you expected. And after that internship, I went back to Michigan Tech. I was a summer break there and met Professor Jay Raja, who's since become a great friend of mine, and went into his office because I saw he was offering a metrology class. And I sheepishly knocked on the door because professors were scary in college. And I said, I see you're offering a metrology class. I did an internship this past summer and I'm curious about your class. And his response was, would you like a job? And he was, yeah, that's literally, didn't tell me about the class.
Right.
Now that I think about it, I did take the class.
Uh-huh.
Nonetheless, though, at the time, he was one of the premier surface metrologists in the United States.
Wow.
And he had worked under David Whitehouse, who at the time was kind of the world's leading premier surface mathematician, if you will, at that time.
Uh-huh.
So I fell into that culture there, and it's been cool.
That's
I can't believe I got so lucky.
yeah. So you've almost it sounds like from early on you were able to be a sponge with all these great minds and learn from some of the best.
Exactly, I did. I feel like my prodigy in that regard is very fortunate that I fell into that. Professor Whitehouse from England was ended up being an examiner on my PhD, and since I consider him a friend in the community, and
Wow.
he's written more papers on surface metrology than anyone around the world. It's crazy,
That's
and he's a
fascinating.
delightful man. He's just a blast to be around. So
Wow.
yeah,
Phenomenal.
everybody should be me in the world of metrology.
Yeah.
No, the rest of me is pretty messed up, but that stuff worked out all right.
Well, that's awesome. So are the rest of us. We all have our own things. Um, Now, when did you start Digital Metrology? When did you found your company?
Yeah, so I came out of my master's and went to straight to Cummins Engine Company. So I was 10 years at Cummins in the 90s as the corporate surface metrologist.
Wow.
So everything that was a surface on an engine, which come to think of it, everything is a surface,
Right. Yeah.
was kind of under my umbrella worldwide. So I spent 10 years, like I say 89 to 99 there. While I was there, I was helping Cummins, helping its suppliers, and the pull from the suppliers to do more became pretty prominent. Suppliers
Just
of
more
measuring,
production.
kind of. It was more about we can better measure something with software that I was writing,
Mm-hmm.
and can we have that software for our other customers?
Oh,
So, a person manufacturing push tube sockets. I did custom software for better analyzing socket geometry for Cummins. And then they would say, wow, can you write something for us for Caterpillar or John Deere or Detroit Diesel or whomever?
wow.
And at the time I couldn't because, I was locked in with Cummins.
Yeah.
And situations like that kept pulling harder and harder. And then also the people making the measuring equipment themselves, like you have a Mitutoyo SJ.
Right.
The other companies like Mitutoyo were saying, can you come work for us and add on more functionality to our measuring systems?
Interesting.
So I was being pulled by the users and pulled by the gauge companies to go help them.
Right.
And finally, the pull was hard enough that I resigned from Cummins. And hats off to Cummins. The day I left Cummins was the first day I came back as a consultant. So it was a terrific relationship. And, kudos to Steve Staley, my boss at the time, who's still kept me on a retainer till this day. It was probably the easiest or healthiest way to leave a job I could ever imagine. So I'm super fortunate.
Right. That's
I was
amazing.
literally at Cummins today working on a fuel injector project, and I've been, quote, resigned for 25 and a half years now.
Right, right. Well, we saw you at the PRI show in Indianapolis. What was that? Maybe 3 months ago.
Yeah.
And I don't know if we told you, but we actually had the opportunity to go tour the Seymour plant for Cummins,
Wow.
and
Some big engines there.
big engines, and we were blown away. So it's obviously Cummins is huge. We knew that, but to see all the details on every step that they go through
Yes.
is fascinating. But also all the engineering that they put into each step is we were blown away. So it's cool to know that you were part of that.
Yeah, the thing that I think a guy in a shop doesn't realize, they're complaining because they can't get to a nut to take something apart, that, in the assembly line, there's tooling and things to make that happen.
Right.
And then there are six other people competing for where you put that nut.
Right.
So the engineering is immense. We have a mutual friend in Glenn Hagley.
Uh-huh.
And Glenn is such a great balance in that conversation of, we get it, we wish we could have, but these six other things are competing.
Right.
And there are so many people and so many systems fighting to put together something as big, say, as that engine you looked at,
Right.
or even as small as the Dodge Ram engine.
Right.
There are so many competing interests, so many people involved.
Yeah. 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 That's something I think a lot of mechanics think engineers, and we have at times, I'm guilty, that
Oh, yeah.
engineers aren't thinking about the mechanic that has to drain oil, and now that drains oil onto the differential or the subframe or something like that. They're like, oh, how come the engineer couldn't think of that? But engineers are thinking, okay, I'm after this one task, and you can maybe elaborate on this, but they're like, I was told to make one engine that fits maybe 3 different applications, or
Yes.
it's, you're limited and constrained on what you have to do, and then you have to make sure that goes to manufacturing, and it's a hard balance.
It's an amazing balancing act in that regard, even a performance balancing act. I was I was in a meeting right out of college, so this is a long time ago now,
Uh-huh.
and we were talking about a cylinder bore situation. And I said, well, why don't we just, do this with the texture and it'll seal more and we'll get more torque. And the people across the table looked at me like, you dumb kid right out of college. And I'm thinking, it's all good. I'm suggesting things that are going to make, more torque, more power.
Right.
And they said the transmission that we buy can't take it. And it's like, oh crap. So, immediately there's
limiting factor.
another system competing with me, making my system the best.
Yeah, that makes sense. Well, that's so good. I think for a mechanic's perspective to hear that it's, you're trying to do your performance balancing act, and that's a hard balancing act to do.
Yeah.
Well, let's before we dive into a few questions that I wanted to ask you, let's get to know Mark. Good. And I think I've made this mistake, but no relation to Mark Wahlberg, right? Different last name.
No,
you're more handsome, right? But Mark is
I'm much more ripped too. I mean, the
Right.
4 o'clock, 400 pull-ups I do. No, that's him, not me. I really hope somewhere, someday, he checks into a hotel and somebody says, oh, we were hoping it was Mark Malburg.
It'll happen.
The number of times it goes the other way is insane.
That's fair. Okay, so if you could have dinner with any 3 people, dead or alive, who would it be that you're like,
Wow,
you
you
just want to
didn't-
absorb their brain?
You didn't put that on the list, dude.
I didn't.
This
That's a
is
surprise
unfair.
one. Yeah.
That's a surprise one. Wow. Well, we would top off the list with Jesus, and we would probably go to on the other dead department. I would like to get inside Albert Einstein's brain just to see how he communicates. Is he really a human or not?
Right.
And then shout out if he's out there. I would love to hang out with Elon Musk for a day.
Okay.
I'm sure he watches the pod here.
I would think so, right? Well, I that's a good top three. Jesus is should be on everybody's list. That's a good one. Okay, what's your favorite book or movie and why?
Wow. So that depends on my state of mind at the time. So
That's fair.
influential, like right now, my brain is kind of into the movie The Martian again. I don't know why.
Hmm.
Maybe it's a Mars thing, but I thought that was fascinating. Um, Matt Damon did a killer job with that. And it was
Very
just an
good job.
intriguing plot.
Uh-huh.
So we'll put that one up there at the top. But if I'm just feeling goofy, there's nothing that beats "Oh Brother, Where Art Thou?" I mean, that's just gold.
Okay.
Book wise, wow. So probably a few. The We'll go Bible, Steve Jobs biography, Elon Musk's first biography, and then Good to Great by Collins have all kind of floated in that top. Good to Great was interesting, particularly for me. I'm an engineer
Hmm.
and I'm running a business, sort of.
Yeah.
So yeah,
I don't think I've read that book. I'll have to put that on my list.
Well, it's kind of dated now because the companies that they touted as going from good and then revolutionizing the company into greatness, half of them are out of business now. So I think you need to make a book good to great, back to bad. But some really eye-opening principles that got me thinking more in a business mind. I mean, yeah, I'm a surface metrology nerd, but I love the people side of it. I love the idea of, what adds value to others, and that's my brain fun.
Yeah. Yeah.
Like right now, I'm listening to a ton of Rory Sutherland.
Huh.
He's a marketing psychology kind of guy, and it's
Okay.
fascinating stuff.
That's another one I'll have to add to the list.
Yeah, so check him out on TikTok because you can get, 2-minute doses of the coolest business case studies ever.
Huh. That
So yeah, Rory Sutherland, big props to him.
Yeah.
Yeah.
Okay. I love it. I love it. So tell us, how do we even, in the world of metrology, how do we even measure roughness and these things? And then maybe we can go into eventually what TraceBoss is. But for somebody that's never been in this world measuring, what would you use, and how are you reading that kind of stuff?
Sure. Hey, we're reading tiny stuff. Let me give a share to that. I love the fact that I get to show pictures because pictures are everything, right?
Yeah. Yeah.
So really, when we're measuring roughness, we're going to use a tiny little point of a diamond. On the right is the tip of a roughness gauge, and on the
Okay.
left is a record player needle. So if you're into vinyl, you're going to be using a diamond or a stylus or a needle, it's called in that space, with a 15 micron radius for the expensive ones. We use a 2 micron radius, and it's actually a cone shaped diamond.
Yeah.
So to measure roughness, we're going to trace a tiny little diamond over the surface. To do that, we've got to pull it along. So these kinds of gauges have motors inside them that pull the diamond stylus along the surface. So it's just like playing a record, only in this case, we're pulling in a straight line. And when we pull this gauge in a straight line, there's a little tiny diamond sticking out of the bottom, say, of one of the most common gauges would be this Mitutoyo. The others are quite common in the space too, but I think you guys have the Mitutoyo SJ like this one.
We do.
And it has a little diamond inside this cartridge with a skid. The skid holds it in range on the surface, and the diamond wiggles up and down and gives us our roughness.
As it drags along that surface almost.
It drags along that surface. So inside this kind of enclosure, there's a little motor that pulls the diamond along, and you can see it here. It's going to pull the diamond. This one, you can see it actually come out on a post. It pulls along. So yeah, we're literally pulling a tiny little diamond along the surface to see the roughness as it wiggles up and down.
And then it just gives us a graph Like I know on ours, it just gives us a little graph of that, the roughness, and then it gives us an average.
Yeah, on the screen itself would have a little tiny display sometimes. So there's a little tiny picture on here. If I zoom in, we might be able to see a little bitty graph on the screen. And our challenge is, one, that graph is very small, and two, that graph will typically auto scale.
Hmm.
So a smooth surface fills the screen, a rough surface fills the screen, and you can't tell them apart. So that's why we've introduced software like TraceBoss, where we can lock the scale. And if it's smooth, it only fills the top half. If it's rough, it fills the whole screen. So we have a better way of looking at data from a gauge like this when we use software like TraceBoss or TraceBoss Plus.
Yeah, that's fascinating. So if you don't mind, now that you've kind of opened that door a little bit more about TraceBoss, can you tell us a little bit more about how that came to be? That is your baby. You created that. We're going to talk a little bit more about it and how to read it and things, but what is TraceBoss for those people that have never used it or seen it?
Yeah. Well, it's a weird story, but I was getting involved with the guys at Total Seal and, seeing how RK and RPK, and we'll talk about those to come, are being used. And I thought, man, the picture would be so helpful for these guys. So I didn't have a customer. I just had an idea that there might be a market for software that helps people
Uh-huh.
understand their surfaces.
Right.
So I got interested just as a side project of, can I write a piece of software to talk to all of these gauges and make a better picture?
Yeah.
The picture is everything when it comes to surface texture. And I have all of these gauges in my office. I'm sure you do too, Miles. I mean, I'm not the only one in the country that does this.
I think I
Um,
have I think we have two of them.
Okay, it's a good start.
Yeah.
Keep going, man. You can do this. So I have all these gauges, and I thought it would be just so cool to have one piece of software and one button that says measure. And it takes control of the gauge, does all the settings, does everything for you. You don't have to worry about all the metrology. You just click measure and get the picture you need. So I worked on this over the course of about a year, just as a back burner. And all of the gauge companies were coming on board with me, giving me details to communicate.
Wow.
And Mitutoyo was holding out. And over time, my friend Scott Ledger made it happen. He convinced the Japanese office to allow the US office to give us access.
Yeah.
And that's been tremendous. So we've got great friends at all the companies, and a platform now where you can see the surface at a fixed scale for any measuring system with one button. It's been terrific.
That's an awesome story.
And you guys have moved on certainly to the Plus version. So TraceBoss Plus adds crosshatch. And another feature that has become really powerful in TraceBoss Plus is the ability to pull up a reference surface, your trophy winning surface you can store. So if you click on the trophy, here's the trophy surface at the same scale, the same height, same width, and I can compare what I loved to what I'm making. And it will also compare parameters, but numbers aren't quite as much fun.
Right.
So this reference surface has become a huge feature. It was truly something that came from engine builders. Engine builders were saying, I've got a surface I like. It would be so cool to have two trace bosses.
Right.
And I thought what would be even easier is just one button.
To have a trophy button that was like,
Have a trophy button. Yeah.
I know this worked for this application. It did what I needed it to do. Let me just duplicate it. Yeah.
Right. And this one on the bottom looks actually more like a drag racing engine, and the one on the top might be a little more of an on-the-road engine. You can kind of see the difference in valleys. Notice how many valleys the bottom surface has compared to the top surface.
Right.
But it's those kinds of differences that are really only possible with TraceBoss Plus.
Right.
So it's just been so cool to get that feedback from the users and turn it into a feature that people really love.
It's a great tool.
Well, you guys use it so well there too.
Yeah.
I love how the fact that it is truly your eyes.
Yeah.
That's very cool.
Yeah. I wish we could see that close and extrapolate all that data, but my eyeballs, and I know everybody else's here, just isn't that good to measure that. So
No, it's beyond your eye
yes,
resolution for sure.
yes. I'm wondering the balance here with when somebody does a DIY project
Hmm.
where they're resurfacing a cylinder head in their garage,
Yeah.
versus a professional shop, someplace like Cummins where it's just, they have a ton of funding, they have a lot of stuff to back them. They have people like yourself, engineers that figure out what is the best surface finish, thickness, everything like that.
Yeah.
For somebody, so let's talk about cylinder heads if you don't mind.
Sure.
When somebody removes a cylinder head
Hmm.
and they have to, whether it's budget constraints or things like that, what kind of advice do you have for that person that is just trying to put on a brand new cylinder head gasket and put it back together, but maybe not the budget to like take it to a professional shop to be remachined? Is there any?
So that's a little tricky because you're a bit outside my lane. I think I would love to interview you and ask you about disassembly and cleanup and
Okay.
how much damage you can do scraping gunk off.
Uh-huh.
Cylinder heads and leakage are really intriguing because your normal roughness measurement doesn't really do much for you.
Mm-hmm.
You can put your profilometer on the surface and get an RA and pat yourself on the back because, I mean, some of these guys are making like mirrors on their redecking,
Right.
and it's way overkill, way over cost.
Uh-huh.
Did a little mini pod with some guys, and they were saying we're making twos on this surface, 2/1,000,000 of an inch, which is like just gauge noise at that point. It's a mirror.
Right.
And my question is why?
Uh-huh.
At the OEMs, they're making 20s.
Yeah.
Their surfaces aren't mirrors.
Uh-huh.
Now, their surfaces don't have leak paths, though. So the difference isn't in did I make a mirror, because
Right.
the gasket surface is going to press in and fill the texture. The surface texture is going to fill with the coating of the gasket.
Uh-huh.
So making a mirror is not a big deal. We want a little bit of traction, but the things that we miss. So here's the money.
Mm-hmm.
What you're not seeing is waviness. Your gauge with a skid doesn't tell me if the surface is wavy. And waviness is the number one thing all the OEMs track when they're working on heads and head decks of blocks.
So you're saying they're not as concerned about like the RA or that perfect mirror finish?
No, they might
Waviness.
care about RZ a little bit. I'm pulling up a slide here real quick, and I'll share that over on my other screen. But they're much more concerned with waviness, much more.
Okay.
So waviness would be. I'm just going to keep this. We're friends here. We're going to keep it casual, right?
Yes. Yes.
All right. So we'll keep it super casual. So the point here is not the roughness. It's not the height. It's the shape. So this is an actual measurement of the actual, head deck of a block. And you might, freak out that it's not flat. The gasket doesn't care about that. In fact, the head can torque down and accommodate that much bow shape. But the leakage comes from all the ripples along the way. So making it flat doesn't help. We can make it flat beyond what's reasonable in terms of cost. We can make it smooth, and that could look like a mirror because your eye does not see waviness. So those ripples that we're seeing along the way, that's where leakage happens.
And what causes those ripples?
Oh, awesome question. Awesome question. It's really awesome because actually I've got another slide. These ripples come from, say, the cutter head not being perpendicular to the axis that's spinning.
Okay.
So a squareness problem with a mill or a fly cutter. So we're spinning, and then once per revolution, it dips low, dips high. Well, a fly cutter is going to dip low and high every cut, but this is usually a multi-insert mill in the high-end, high-volume production settings. So the entire head is tilted. Let's find out right here. So if this cutter was tilted, once per revolution, we'd get a wobble, and that would kind of introduce this kind of thing.
And And that, I think you talked about this when you came down and visited us last year. But a gasket or a piston ring or something can seal against like an oval type shape, but
Yes.
something that it's trying to bend against those wavinesses.
Right.
Well, that's a terrible term, but
It
the
is those
waves.
well, yeah, that waviness stuff.
Right.
Yeah, right.
That's what it can't seal against.
Exactly. So we can have a surface that's wavy as long as it's gentle wavy. Now, to look at this in real life, these are two surfaces that came from the same block line. They both have the same amount of a hump. You see that hump in the middle of it?
Right.
Well, this one has several little humps of the same height. They both have some valleys. They both have some fuzzy roughness. Those two surfaces will measure with the same numbers.
With the same RA numbers?
Same RA number. In fact, there are other numbers, like there's the same waviness. There's a W number called WT for waviness total. The height of this hump is the same as the height of those little humps. So it's like, here's one mountain of that height. This one has 4 or 5 mountains of the same height.
Right.
So these surfaces have the same numbers. So again, if we just looked at a gauge and looked at the numbers on the top of your gauge, those two surfaces would say they're the same. But when we put them in an engine, the gasket will follow this one,
right,
and have very little leakage, but the gasket can't follow this one, and we have a lot of leakage.
So if that's a cylinder head surface or a block deck surface,
yes,
on the top one should be good.
Yes, it was good.
It was
worked.
good.
No leakage.
But on the bottom one, you're leaking.
You're leaking. Yes, you are.
Okay.
But those numbers couldn't tell the difference if we are blindly buying parts and the parts were checked, or if we're blindly making parts and looking at the numbers on the gauge and not doing the artwork that you do of investigating more deeply. Mm-hmm. Investigating more deeply in the roughness realm means looking at these shapes in the picture and deciding, can a gasket live with those bends and peaks and valleys? A skidded gauge like the Mitutoyo SJ210 here, the skid is going to follow the humps and the stylus won't see them. Mm. So your gauge will make you think you're smooth and flat. We need a skid-less gauge where just the diamond touches the surface and a precision gauge pulls it in a straight line. So we won't know we have waviness until we graduate to a different gauge.
Right. Okay.
So that's the thing that I think is the biggest difference in the OEM world versus the shop world. Now, we can still get close. If we use something like Fuji paper, we can essentially simulate what a gasket might do with the paper, and the paper will show contact at points. And the Fuji paper itself will have an imprint of contact, and gaps will show leakage.
Do you mind explaining to us what Fuji paper is?
What Fuji paper is this, let's say, magical paper that when you squeeze it, little tiny ink bubbles are going to burst inside. So on this leaky surface, we're going to have little red spots that show up in the paper here, here, and here. Here are some examples from our friend Zach Fothergill, ZF in Colorado. This is Fuji paper on a Subaru block. So you put this plasticky stuff, and it's actually cut to be the shape of a gasket. Right. And you put this between the block and the head with a gasket many times just to apply the pressure and see where there's less pressure. Less of those little ink bubbles got burst in this zone, where throughout this zone, all of the ink bubbles were burst and we have nice coloring. So it shows us sealing, if you will. And if there are areas where, say, machining is leaving gaps or valleys, we might see gaps in the red or the coloring of the Fuji paper. So really cool way of seeing where you have contact and pressure versus where you may have leakage.
That's way cool stuff. That's so interesting to see.
Fascinating.
Yeah.
Yeah.
The,
Chuck Lynch has got some videos on this topic as well. Chuck can do a master class on using Fuji paper. Really cool. You can see around the periphery here where there's loading around the voltage joints and not in between. But more importantly, gaps right here where there's not sealing.
so this will help all those Subaru guys out there that are blowing head gaskets all the time.
Talk to Zach. He lives in that space, and he's got some things dialed in now. So yeah, check out ZF. Good stuff.
That's cool. That's awesome.
Now, I'm a big fan of when we tear things down, we look real closely to see where they were touching also.
Yeah.
If we can see patterns as we tear something down, that's a big smoking gun to me.
That failure
Do we
analysis.
see stripes in? Sorry, go ahead.
Like that failure analysis, not just
exactly
pulling something apart and saying, okay, let's build it. Like finding out why did it happen? Why did it do that?
Right. So think about pulling a conrod out of an engine. Look inside the bearing shells. Do you see stripes?
Mm-hmm.
If you see stripes, there might have been waves on the crankshaft that were imprinting into the bearing shells.
Right.
So those kinds of things are a big deal to me. Is if you don't have the money to buy expensive measuring equipment, maybe the engine will tell you.
Right. So that answers the question about a cylinder head gasket. That's what we really need to be concerned about. It's not necessarily the finish is important, but
ish. Important.
Yeah, but really not the biggest factor. It's the waviness.
Yes.
I feel like I'm saying that wrong, but
you're absolutely saying it right. No, that's 100%. There's roughness and there's waviness.
Yeah. Now that's the same thing on a cylinder as well. That for a piston and piston ring that's what we need to be concerned about as well. Is waviness
right?
Correct.
Well, in that world, we take waviness and we use a different word for it, but it is waviness, and we call it roundness or cylindricity.
Okay.
And yeah, that shape is very important because that's what the ring is going to fight to conform into.
Right. Now,
and again, we can use a teardown as our eyes when we don't have a $250,000 Incometer. Look at it as you're disassembling and say, are there spots that are more polished than others?
Right. Is that different than like your RVK and RPK?
Yeah, so let's go there. Since I've got a screen and stuff I can share,
This is something that you've trained our machinist on. For those that don't know, and I think we touched on a little bit earlier, Mark has developed the TraceBoss technology, which is like a giant eyeball that checks the angle of the crosshatch, checks different surface finishes, and other things like that. It is really one of the best tools that we have used to know, especially when we're honing a cylinder wall, is it the right finish? Do we have what we're doing? Is it right? And will it work for the application the best? Will it retain oil in this specific engine that we're doing the best? It's really an amazing piece of technology. I feel like every day we're still learning it. And obviously I know it far less than our machinist, but they have a cart that they wheel around, and it's very sacred because they pull out that tool and they go to town. So if anybody's watching, what we're looking at is what I'm used to seeing from your TraceBoss.
Yeah, so TraceBoss is right at the microscopic level. I mean, this is a half inch of data along the roughness graph, and then a snapshot of maybe 40 or 80 thousandths of data of crosshatch.
Yeah.
So we're looking at the microscopic scale of roughness here, which is where sealing happens. It's where friction and lubrication happens. So there's that microscopic texture, but there's also a macro kind of shape going on where there are spots that are going to be tighter and looser just based on geometry. Now, this is a loose liner engine, but we can see in red the areas that are going to be tight on the piston ring. This is an interesting one because this actually is 3 lobes. It's triangular at the top.
Ah,
And a 2-point measurement is going to measure that as perfectly round because you're going to be on a tight spot on one side when it's loose on the other.
you're talking about like
And
a
if I were
dial
to
bore gauge that you
a
just
dial bore
rock
gauge,
back and
yeah, would
forth.
show that as perfectly round.
Mm.
Yeah,
Now,
because
was that out of a running engine, or what is that cylinder?
this was a teardown,
Okay.
so it was a used cylinder.
Okay.
And yeah, it was interesting to see that there was distortion in terms of even ripples on one side. There's a lot going on here that we would just never measure in a shop because we don't have the $250,000 system to do this.
Right.
But that's not a bad thing because what we also have in a shop are people that care.
Mm-hmm.
And they will, have time to look inside and see that on, bore number 2, I've got wear 45 degrees off the thrust direction. Why would that happen? It should all happen in the thrust direction. Or something like that, where we can see patterns and start to relate them to the rest of your knowledge.
Yeah.
Maybe it's cooling more in one area, maybe it's distorting more in another. So the looking inside a bore is almost as good as using a $250,000 measuring system.
Yeah.
But you need to start thinking about that's something to look for,
Right.
is looking for these shapes, not just spinning your dial bore gauge around inside. I was going to see if I had another data set. But yeah, that kind of makes the point well enough.
Yeah. Yeah. That's fascinating. I don't know if I've seen that, but I would never think that a cylinder would look like that.
Yeah, it's at the finest of scales, nothing is perfect.
Yeah.
So, and that's truly the realm we're in. I heard an interesting talk, and I thought it really struck me is in the Revolutionary War we could get by with just measuring diameter of musket balls.
Uh-huh.
if they were all the same size, we can trade musket balls and we can both shoot bad guys together.
Yeah.
In about the 1970s and 80s, we started caring more about where things were. Yes, it's at the right size, but is the hole in the right place to receive the bolt?
Right.
So position became more important.
Mm.
And squareness, and even some things like flatness came into the conversation in the 1970s and 80s.
Yeah.
So we went from size to more orientation.
Yeah.
And today, the pieces that are left are shapes.
Yeah.
It's the right size, it's in the right place, but are we putting the right finish on it? Are we controlling the waviness?
Right.
And that's where the gains are now because we've used up the other stuff.
Yeah. Yeah.
You guys, size is super important. You've got it dialed in, but that's the baseline. What can we do beyond size to make things even better?
Well, I'll have to admit a flaw, and something we haven't done for a lot of years, but we used to have an old Sun and Hone, and we would just use the dial bore gauge. We'd rock back and forth. Yeah. And at that time, this was years and years ago, but because we have the Rottler H80 that I think you've seen. But when we were doing that, we were just like, okay, we'd rock the dial bore gauge back and forth. Did we have the right size? Great. Did it look good as far as the finish? Yes, it looked like a mirror. And at the time we thought, wow, that's great.
Yeah, shiny is good.
Shiny's
right?
good. And so this was a long time ago. And we found out we had a few engines that would burn oil. And we're like, well, our finish looked like a mirror. How can that be? Like it was just dialed in. But the more that we got educated, we're like, oh, well, okay, we didn't know.
Well, and you've raised a fascinating point. I've been involved in projects before, let's say camshafts, where we made them smoother and smoother and felt like we were getting better performance until we got too smooth. And there was no way of retaining a lubricant on the surface. And then you start to get welding, particularly as you start up and there's no oil in the interface, and metal will weld to metal if it's too smooth.
Yeah.
So that shiny surface does two things. One, it exaggerates roundness errors because there's nothing to break in.
Mm.
You need a fuzzy surface if you've got bad roundness.
Yeah.
If your part is out of round, let's say for a cylinder bore, your piston rings are going to eat the tight spots. But if they're smooth, it's very hard to eat into that and make it round.
Right. And that's where you can burn oil.
And also then the gaps in between, you can burn oil as well, right? So if
Yeah.
you're too smooth and you're so out of round that the ring can't follow it, that's where you burn oil badly.
Right.
So what we do in, again, at the OEM level is we don't care so much about total out of roundness. We have advanced measuring systems that actually plot the shape, and we look at 30-degree windows to say, how much does that surface change in a narrow region? Because that's what the piston ring is going to fight.
Right.
The piston ring can handle out of roundness if it's oval.
Right.
The piston ring can't handle out of roundness if it's a local ripple.
Okay. Like a triangle or another.
Well,
shape.
even worse. Let's think of if there are 6 bumps, if you have 6 head bolts.
Mm.
And as you squeeze those down, you put 6 ripples in.
Yeah.
So it's even beyond oval. It's local ripples in the roundness.
Right. Right. So that's where
And
that's where a torque plate would come in, is trying to mimic what a cylinder head would do, so that you can hopefully get rid of those hard spots.
Yeah, I actually was involved in a study once where if we did a torque plate and torqued it wrongly, ring seal was a million times worse.
Oh,
because you are affecting those little narrow bumps, not just oval,
right.
but the 6 bumps.
Yeah.
And there's a table, and I think Total Seal has it, I think Mala has it, where if you've got ovality, our piston rings are just fine with a ton of ovality.
Mm.
But as soon as it turns triangle, we can only handle about half as much.
Wow.
If your shape turns square-ish with 4 bumps, it's way less. And if you introduce 6 bumps, you can't tolerate any.
Interesting.
So it's the number of ripples the ring is trying to follow.
Right.
Which is really, if you think about it, think about the picture, it's how much bend do you need to follow at various points around the circle. 6 bumps are going to have a lot of little bends in it.
Right. Right.
It's got to bend 6 times.
Right.
And that thinking of not, I got the same diameter everywhere, that's not what the ring sees.
Right.
The ring sees how much do I have to bend to fill this gap in front of me right here.
Right.
Gaskets work the same way.
Yeah. Yeah. That's fascinating. So what about, I guess that leads me into think, so that's different. The roundness is different than your RVK, your RPK, and things like that. Can you explain that? What do those abbreviations stand for? I guess if you can educate us there, and then why are those important to kind of follow up with that? Because I know that when you're building like a drag engine or something like that, that may not live for very long, you're not concerned about it lasting for 10,000 miles even,
right?
Versus a daily driver that you're hoping to get 1 million miles out of. Your finish is going to be different, right?
It is, and it's a weird trade-off because your daily driver, you're really concerned about oil consumption, and if you're in California, you're worried about emissions and things.
Right.
Where the drag racer doesn't care about either.
Right. Right.
So that's a huge difference. So let's talk first about roundness versus roughness.
Okay.
Let me reshare, and this is gonna get ugly because I'm gonna try to draw on the screen. So everybody's gonna have a good laugh here, and I can just see the comments coming. So roundness is the big distortions along the way. Now I've really amplified them. It's not square, but it might be a little tight in some spots, and I, exaggerate it up.
Right.
If we think of that as the diameter of the bore magnified in terms of errors. So I'm going to do a little little class on the roundness plot. If that's perfect, and if my data is measured, well, that's great. Here we go. If I measure something a little bit inside that, I'm still round, but when we plot it, we really plot it as a huge error, and it looks like we blow it up. If it's in a little, we make it plot in a lot.
Okay.
So we really screw up your brains in roundness.
Yeah.
Roundness is messed up. If you ever send something out to get a roundness plot, it's going to look like it would never be round.
Okay.
But at the same scale, if we're talking about surface finish, I'm talking about valleys that are about, here and here, and my entire trace length is only this big.
Right.
I'm talking about the microscopic stuff on top of that shape.
Yeah.
So, the roundness is the entire diameter of the feature. Roughness is literally only half of an inch of a trace.
Right.
So it's kind of like the low notes are roundness and the high notes are roughness in terms of music.
Right. Okay.
They're totally separate.
Right.
So roughness is not roundness. Roughness is on top of roundness. So I've got some round shape with valleys in my plateau finish, and then maybe some peaks on it. But you mentioned RVK. RVK would be the valleys on top of whatever round shape you've produced.
Okay. So that's the valleys, and that's where oil is retained.
Right. So these valleys right over here, that's where oil is retained, and they show up white in the crosshatch microscope.
Okay.
So that's literally where we've created gaps in the surface to hold on to oil. Ironically, well, maybe not so ironically, I have my favorite surface of all times on my desktop, and that is a scanning electron microscope picture of plateau honing.
Wow.
Yeah, I see you laughing at me. I know, I'm a nerd. I can admit it. But that is what the surface really looks like. And you can see the gaps, and then you can see that it's flat and kind of smooth in between. So that's what plateau honing looks like in 3 dimensions, way at the finest scale.
Yeah.
The principle is actually quite interesting. It's trying to take that noisy looking surface and break it into zones. So RK is kind of the height of this middle zone of the surface.
Okay.
It originally started out as kind of the word kernel. It's the middle of the surface. That's your running surface. And then RPK literally stands for the roughness profile. We're going to look at the peaks in the K family. So RK is a number, and then everything else kind of is part of that family. So RPK, part of the RK family. RVK is the average depth of the valleys in that family. Now, one thing to point out that I would like people to really lock onto, RVK isn't really calculated as a depth. It's really based on the volume of the valleys. So in this case, I've got, a bunch of really deep valleys, and my green zone isn't even close.
Right.
So the green zone on this screen is actually calculated based on the volume of the valleys, not the depth. But we tend to use it to describe, do I have deep valleys? So it's measured as a depth, but it's calculated based on an area or a volume.
Now, what should somebody that's building just for short term, like drag racing, would they want deeper valleys, or where would they want to be with their finish?
Yeah, so that's been really interesting. In fact, I think the industry has been learning that. And it's been fascinating to me to watch this, because let me back up a little bit. My history has been production engines on the road with EPA breathing down your neck.
Right.
And in that space, we want a lot of material at the top and just barely enough oil holding valleys underneath.
Because you don't want to be burning oil, and then the pollution and everything like that is you're trying to minimize that.
We are. And in fact, that even at the expense of scuffing and other things, because if the EPA doesn't like you, you can't sell it at all.
Right.
So we've got to start there. We've got to start with meeting emissions and not burning oil. So managing a lot of material here so we don't have extra oil at the top of the bore that gets burned.
Mm-hmm.
Well, what we've found, and again, I'll point to Lake and some of the Total Seal videos are really great on this, is we're finding that for racing, more valleys is better. With more valleys, we can actually use, in their terms, Lake Speed Junior trademark, the oil is your gasket.
Yeah.
So
Yeah.
by having more valleys, we can have more oil at the surface and that better sealing due to oil rather than metal to metal. And we're seeing that in drag racing. Just putting loads and loads more valleys in the surface seems to produce a better seal, better horsepower, and sprint car, better vacuum. So valleys keeping the oil at the surface are great in racing, but we just absolutely could never do that on the road.
Right. Because those deep valleys, if you have those, that's going to leave more oil on the cylinder wall.
Yes.
But that's also going to consume more oil.
Right. Exactly.
Okay.
It's going to give you the gasket effect of sealing and keeping fuel contained.
Right.
You'll actually burn some of the oil, which, it combusts sort of too.
Right.
But all your benefit is in that better seal for the rings, but that better seal for the rings through oil can't be done on the road because you're blowing black smoke out.
Right. Right. Can the finish change over time? Let's say you get something that you've honed and plateaued honed and for longevity. So you have not deep valleys or anything, but you're running it, and in time, can that surface change at all, like on a cylinder wall, or does that pretty much stay the same?
So it does change. I mean, as an engine runs, we are wearing things in.
Uh-huh.
In fact, one of my earliest projects was to make an engine that doesn't need to break in.
Oh.
So we made the plateaus super smooth, mirror-like plateaus. And as we worked our way towards that mirror-like surface, the engines would break in instantly. Just in seconds, they were flat. Everything was broken in.
Right.
And if we went too far, then we would never break in. Because we had, again, that shiny, smooth surface up against a piston ring and nothing to rub away the high spots.
Right.
So the trade-off was to make enough roughness in the peaks to accommodate the out of roundness in the bore.
Yeah.
So think about that again. The bore isn't perfectly round. There are going to be tight spots.
Right.
In those tight spots, we need roughness to break in.
Yeah. Is that not bad for the piston ring? I mean, if you have, I guess there's probably a perfect balance, so to say, like you're talking about. But if your peaks are too high, could you potentially damage the piston ring?
Oh, absolutely.
Okay.
There is a total Goldilocks situation here.
Yeah.
If it's too rough, then you're just eroding all that material away, dumping it into the oil and that kind of thing. So it's hard on the engine. And also it's going to take a lot more time to break in, and you're going to introduce more ring gap and everything else. So we want that Goldilocks spot, just enough peak roughness to accommodate any out of roundness.
Yeah.
And then things should sit still for a while.
Yeah.
Fascinating. We've looked at million-mile engines in diesel that still have the valleys. So it hasn't worn the peaks down past the valleys. They still exist.
Wow.
Looking at drag racing engines, engines that have gone a full season and they've barely changed.
Wow.
Now think about the drag racing engines. We've got all these valleys, all this lubrication.
Yeah.
There is no real wear.
Right.
So we know there's a lever. We know surface texture really matters. The part that frustrates me is there is no recipe. I can't say, hey, Miles, you're working on a Power Stroke or something. What should you hone it to? I don't know.
Yeah. It's a trial and error and trying to get it as close as possible is what you're saying. It
really is. And the ring manufacturers are the first place to start because they are the side that is going to be affected the most.
Right.
And I just saw a post recently, somebody sharing, a recommendation from a ring manufacturer of RK, RPK, RVK. That's a pretty big window.
Yeah.
Inside that window, there's a lot of room that you can play with the surface. You can add twice as many valleys, and those numbers aren't going to know the difference.
Okay.
So there's still a lot of experimenting to do. Ironically, the cylinder bore, I know we're spending a lot of time there, is the most published, researched surface in the world.
I did not
If you
know that.
take every surface in the world and all the research that's been done on it,
Right.
and I'm talking medical surfaces, optical surfaces, everything else, there's more paper produced writing about cylinder bores than any other surface.
Interesting.
Yeah, and they still haven't figured it out. Neither have I. Honestly, a guy like you, especially a guy with a hone and a dyno, they know more than any university about their engine.
Yeah. Well, I mean, it's the one you're spending the most time with, and you're trying to find that perfect balance of, okay, what does this customer need? If we
Yes.
do this, what effect does that, does it have? And
Right.
are we going to see them back in 10,000 miles or 500,000 miles? And
Mhm.
we just, it is not, it's good to hear that it's not a perfect science, because sometimes I feel like there should be this perfect recipe, and it's like, okay,
Yes.
what are we doing wrong where it's not perfect? And
Sure.
and
And
we're still
and
learning, and I hate that
so
we're still learning, but it's good to know that learning is, we're getting better and better, but sometimes it's frustrating that it's like, how come we just haven't learned it, checked it off the list, and said we're done, we figured
well,
it
I
out.
think there are two pieces to that. One is every engine and every vehicle is unique.
Right.
Is it a daily driver to the grocery store, or are you hauling horses in Colorado?
Right.
So there are different duty cycles, there are different vehicles. The other thing that is really worth noting is our numbers that you see on the screen. They suck. They're terrible. Those numbers are bad. The same surface can have the same or two different. I'm sorry, the same numbers will show up for two very different surfaces.
Mm.
To try to describe a surface with a number is like trying to describe a concert based on its decibels.
Huh.
Hey, Taylor Swift was awesome. She was 105 decibels.
Right.
Well, so is a chainsaw.
Yeah.
Numbers don't describe it.
I'm sure Taylor Swift won't like that, but
Yeah,
that's a good example though. It's it doesn't quite do it justice.
Right.
Yeah.
So we can't put numbers on a surface, just like we can't put numbers on a concert.
Right. Huh.
So
That's fascinating.
the key there is that you're starting to recognize the picture.
Uh-huh.
That when you guys are honing, you see the numbers to say, yeah, we're in the box, but what is the shape?
Right.
Do we have the same valleys we had last week? We've got 12 deep ones instead of 20 shallow ones.
Yeah.
And that picture is so much more worthwhile.
Yeah.
Because our numbers can only get us close. And I think that's where the struggle is, even with, the university publications and the research.
Mm-hmm.
The research won't give you the answer because the numbers they work with aren't good enough.
This is, I'm trying to absorb all this as you're talking. This is one of those, every time we meet you or talk with you and learn from you, I'm like, okay, I think I got it. And then I'll rewatch it and be like, oh, I gotta keep educating myself.
Let me drop it in one statement.
Yes.
Everything I talk about, look at the picture.
Okay.
I'm serious.
Yeah.
The profile graph, the picture of the worn part, everything I do is help people describe something that's a picture.
Right.
And over time, your eyes will dial into the shape of a picture.
Yeah.
Interesting story on the picture. I did a project for one of the automakers, and it was a head deck situation. So it was block head deck, and they wanted a special measurement of waviness.
Uh-huh.
And they came up with a number, an equation to measure this part of the surface to do with waviness.
Right.
And they asked me to build it into the gauge so that out on the shop floor, the operator would click measure, and a screen would pop up with this magical number they invented.
Right.
And so they said, we want you to, like TraceBoss, you click measure and things happen.
Right.
We want you to write software, you click measure, and our magic number appears either red or green.
Okay.
And so I came back with a quote with a nice graph like TraceBoss, a graph across the top, and their number red or green.
Mm-hmm.
And the response was, we can't have a picture of a profile graph on the shop floor because then we have to train our team on how to use it.
They wanted a literal red or green, like green is good to
That's
go.
it.
Send it.
Good to go, red or green.
Yeah.
Red, green. And I said, I can't do that. This is a surface. What if somebody bumps into the gauge? I can't give you red or green. That's just not Mark Malburg's deal.
Right.
And they said, well, we have to. I said, I can't quote it that way. And they said, well, make the picture small.
Oh.
And so I didn't. I made the picture huge. But the interesting deal was they said, we can't train our operators. We installed the software on the floor, and eventually they just said, fine, we'll take it. The quality manager, so this is the guy that manages quality for the entire block line.
Right.
I was talking to him about 6 months later, and he said, one of my operators came up to my office yesterday and said my picture changed.
Oh.
He was never trained. He didn't know what he was looking at.
But he just knows.
Over time, he knew what to expect.
Right.
And sure enough, the number was green. It was a good part. The quality manager went down and looked at the graph and said, oh man, you got a broken insert. This thing's going to leak like crazy. The number didn't catch it.
Right.
But my picture changed.
That's where it comes in, the education of what you're looking at, or at least a picture is what you're talking about.
At least in that case, I would have given education, but we couldn't. There was, rules.
Right.
But you start to recognize things like, I would recognize your voice on the phone.
Right.
Or you ever hear a TV commercial and hey, that's this actor, even though you don't see them.
Right.
Well, your eyes work the same way. You can tell who that is walking across a parking lot based on the way they walk.
Right. Right.
You don't see their face.
Mm-hmm.
If I showed you 15 surfaces of cylinder bores and then slipped in a crankshaft surface, you'd know.
Mm-hmm. Because
your eye picks up on a signature.
Right.
And I think that's so key to our shops, is that they start to just pause and take a mental picture of that surface.
Right. Right. Well, I know when they're at our home and I come over, and I'm definitely more of a picture, like, okay, that looks right. Like,
yes,
that looks like what the other 10 or 20 have been.
Right.
I think we're in the right area. And then I'll ask them, is that correct? Or are things still looking good? And they'll say yes. And they'll play and manipulate it a little bit more and dial it in better. But I'm glad to know that as a pitcher guy, I'm like, okay, I'm not too far off.
Well, and that's been the huge benefit. TraceBoss locks the scale.
Uh-huh.
So you're always looking at the picture at the same scale too. It's not auto scaling. So smooth ones fill the screen and rough ones fill the screen.
Right.
So to have a consistent picture over and over again is really huge.
Yeah.
And I think people are embarrassed, like, well, I don't understand the numbers, so I just look at the picture. You actually know more that way. So keep looking at pictures, Miles, and you're my hero.
Yeah. Okay. The picture books in elementary paid off.
They did. That's right.
Okay. What about AI? Has that affected your business or your world at all? Do you use any AI? Do you have any experience with that in your world or in metrology?
Yeah. So AI is interesting in a couple of spaces. One of the areas that I'm deeply intrigued by is, can we do something better with torn and folded material in honing?
Okay.
Because it's kind of there in the picture, but we don't have numbers for it. Our challenge with AI in that regard right now is it can separate maybe good and bad, but it doesn't do a good job of giving a measurement. So I'm intrigued with where AI is going to help image processing go. So I'm really standing by there. I had some conversations with the professor, and he said AI is not quite there yet in that realm.
Yeah.
But I use AI almost daily when I'm developing software.
Okay.
I'm using it to develop math with me.
Okay.
So I'm describing a math scenario and having it write the 200 lines of code, and then I go back and check it.
Yeah.
So the checking is huge. I feel like AI checking might be the next career that people start going to school for, because so on my screen was RA and there's RZ next to it on the screen. You see it on TraceBoss.
Right.
I told ChatGPT to give me a subroutine that calculates RA,
Okay.
and it does. And then I asked for RQ, which is standard deviation, and it did. And then I asked for RZ, and it gave me a different form of standard deviation, which is totally wrong. But AI is taking bits of knowledge and trying to extrapolate beyond what it learned. Well, if that's RQ, maybe RZ is similar.
Right.
And it gave me an equation that said RZ equals this, and it was completely wrong.
Interesting.
So I use it very, very regularly. I'm writing hundreds and thousands of lines of code with AI assistance to do the typing, and then I'm doing all the validation.
Yeah.
Now there is AI assisted metrology in other areas, like for car bodies, for machine tools, where it listens to a noise signature to find out if a tool is breaking down. It's showing up in a lot of places.
Yeah.
My concern is this. If you have a dial bore gauge, you can stick it in a ring and know that it's got the right size.
Right.
You put it in a known ring gauge and zero it, or you zero your gauges, you calibrate your gauges.
Right.
How do you calibrate AI?
That's beyond me. I don't know. I don't know if they're
You don't really, right? Yeah. Because it's learning, and what if my gauge learns its way down a different path than your gauge?
Right.
And then our measurements don't agree. I'm selling you 1,000 parts. I say they're good, and you won't pay me because you say they're bad.
To my calibration.
Right. Yeah. Or your AI engine in your gauge interpreted something differently.
Right.
So AI in metrology is an interesting challenge because everything we do needs to be traceable.
Yeah.
We need to have a result that everybody can agree on and goes all the way to our national lab and agrees with them.
Yeah. Yeah. That's fascinating.
Yeah, I'm intrigued by it. I'm blown away by what AI systems can do. Yeah.
Now you had, I think before we started this podcast, you had a image up on your computer, and I wanted to make sure that we covered that if it's something you wanted to cover. It looked. Do you know which image?
I want to see if you can describe it. This is hilarious.
I was going to say it looked like an Italian cookie or something, but that's way far. I don't know what it is.
I'm just messing with you. So that's hilarious. And
yeah, so my curiosity was piqued because I don't know what I'm looking at there.
That's so cool. No, and hey, we're friends. It's cool.
That does not look like a cookie. Okay.
That does not look like a cookie. I'm just messing with you, Miles. I think you're awesome. So I want to bust your chops a little bit and see what you remember.
Do it.
Yeah. And just an aside, I love what you're doing, being the questions that other people are asking. So keep that up. Even if you know the answer, ask it anyways, because you get to hear from people. And I love what you're doing. One of my favorite hosts is Kevin on This Old House. He's a master carpenter, but he still asks the questions so the audience can learn it.
Yeah.
So stay in that space, and you're doing awesome. This is a Moly piston ring.
I would not have guessed that.
Yeah, so it's a little segment. It's only 2 millimeters. So, just a tiny little part of that. And this is courtesy of my friend Keith Jones over at Total Seal. And we've talked in the past about how cylinder bore finishes have had to change with rings. And in the era of Moly rings, the Molly rings had a whole bunch of porosity.
Ah,
And
those are those
if
little yellow
I,
spots.
yeah, the little yellow
Yep.
spots are low. If I flip it over, you'll see them sticking
Oh,
through in the
yep.
bottom. That is just like the valleys of plateau honing. In fact, it's about the same depth, maybe a little bit deeper than our plateau honing valleys, and it takes up about the same amount of material. So I'm going to level that out. I'm going to flatten this sucker so we can see it better. So this is that surface flattened, and now they're blue. We can see those blue porosity bits hanging around.
Right.
And in that era, the ring would carry the oil, so we could just do a single peak hone and not have to worry about plateauing our bore because the ring was carrying the oil for us.
Wow.
But you were absolutely right that um, cookie-looking weird lumpy thing is a small section of a piston ring. And yeah, I was just intrigued to see how I could characterize how much porosity is in that compared to RVK in plateau honing.
Yeah.
So that was my afternoon fun today, just as a side project.
Your definition of fun is, I think, a little bit different than some other people's, but it's fascinating. I think it's so exciting, and that's why we enjoy talking to you so much. This is the stuff that for us translates. The more that we educate ourselves, and that's why I love asking these questions to educate myself, because we try and translate that into our customers, all of this information into something like an engine that is going to last them for as many miles as possible. So all of these details it's exciting for us, because it's like, oh wow, we can maybe try this differently, or we can experiment this way and see what kind of result we get. And that's what we love.
I love that about you guys, that you're not just, trying to bang out engines or bang out repairs, but you're interested in the science. I mean, the fact that you would buy, two profilometers, you got a lateral one and a standard one, to be able to see and inspect and make sure you're producing something of quality. Hats off to you guys, because that extra mile you go, get it, Miles?
Yeah.
is so valuable in terms of the return customer, in terms of, the durability. On these, the ring on the right is a chrome ring, and you can see there are valleys kind of running along that ring. So yeah, this was again, Keith and I are going to be putting these together in terms of, do I have a tinitride too? There's a tinitride. So that's titanium nitride, totally different shape, and these are on the same scale. I think you guys may have seen I had 3D printed cylinder bore surfaces. I'm going to 3D print these so you can hold them up against it and see what the actual interface feels like.
That'd be cool.
So, but that curiosity, like you guys measuring and exploring, that's where I live my life also, is measure and explore and see what's happening.
Yeah.
The red spot in the middle is because it is a ring. So that is a piston ring. There's a crown to it.
Yeah, that's just saying that it's peaking right there.
It's the radius. Yeah, the ring is a curved ring.
Right.
So yeah.
Yeah. Well, this is fascinating. Mark, is there any other things that you want us to cover, or that you want to point on, or you're so full of wisdom? Is there anything that you would like to share with anybody, whether it's just a personal thing, or just a knowledge thing that is in the industry that people need to know about?
One thing that I would share that I think people don't appreciate enough, say in the shops, the race shops, the repair shops, is the sense of community I have found is incredible. So I've been a corporate Fortune 500 company market for so long that I've gotten to know guys like you, and countless guys that are truly trying to do a great job, that are just terrific people. And it's insane to think that people are posting TraceBoss pictures on Facebook saying, look at the surface I made.
Yeah.
And they're sharing at that level, and people are giving them thumbs up for what they're doing. And I love how people are learning from each other. And man, the people that are in that space, you don't appreciate it as much until you're in, say, a big three or a company like that where they think everything's proprietary.
Right.
And man, I can't thank you enough for a chance to talk about this stuff with you.
Yeah.
So yeah, to close, thank you so much that I get to be part of your community.
Yeah.
It's been so rewarding.
Well, that means a lot. I do totally agree with you that this community, this, whether it's through social media or just, seeing each other at PRI or one of the trade shows or whatever it may be, like this exchange of knowledge, and constantly learning we still have so much to learn. And so it's so nice to have people like yourself and others in this industry that are just so open about teaching others what they're learning and what their struggles and what their successes are, so that others can gain from that. And it's an awesome thing to be a part of. And we really do appreciate you. You've helped us so much, whether it's coming down here and educating us, showing us how to use your technology, the TraceBoss alone, everything like that has just been is so phenomenal. And it's nice to know that we still have so much to learn. So we're excited.
And you're going to learn faster than I am in your space, because you're dealing with it every day. And it's so cool when I have a conversation with you, or you got running the hone, or places like, I'm seeing this and I know if I add a stroke I can fix that. I'm like, that's so cool, because you're using the eyes I can help provide, but your brains.
Yeah.
And that's awesome.
Yeah. Well, thank you. We're a part. We're happy to be a part of this community as well.
Yeah.
If anybody out there watching has not seen Mark, you've got a bunch of YouTube videos. You've been on a bunch of podcasts, trainings, other things like that. Thank you for being on this podcast. You really need to go check out this guy, find everything that you can out about him, because the knowledge is so invaluable, whether you're in your garage trying to do something or going to take it to a professional shop or in a shop, anything. Mark's the guy to know and to learn from. And I'm telling you, we've gained so much valuable information from him. Thank you again, Mark, for being with us on another episode of the Builders Lounge. It's such a pleasure to have you. Thank you very much.
Thank you so much for having me. It's great talking to you, Miles. Thank you.
Thank you, everybody, for watching. We'll see you next time.